Hi, hello. My name is Bukumi, and today I want to walk you through the sentiment analysis project that was given to me by Law Pavilion. So, this is a very simple app, and I call it Sentisis. This is the repository, and I'm show you shortly the web interface. So, this is the display Sentisis. So you can access this by going to docdns.org is a free domain name system platform, and it is hosted on my workspace VPS, and this is currently running and works fine using the distill bird running on a CPL, this a CPU virtual space. And if I type in I love these and click classify, it goes over the classification, returns positive, sorry, yeah, positive at 97.9%, neutral at 1.2%, and negative at 0.9%. So definitely this is the highest one. And if I change this love obviously to hate, that should change the meaning. Yeah. And negative as 98.0%, neutral at 1.5%, and positive at 0.5%. And if we look at this, it is very, very, very fast. And of course, this is serving from a cache. This is cache because I've typed this exact thing before, like some minutes earlier. Okay, let me change it. I hate this a lot. Yep. Okay, so it's now, yeah, it's computed in 1.128.7.27 milliseconds. Very, very fast. Negative. Now it's not serving from cache, but if I remove this, it will serve from cache. So I'm using Redis caching. Yep. So I'm using Redis caching to wrap around the API, and this makes sure that the computation is efficient and it doesn't recompute queries that it has received before. So this save computation and it makes it as fast as it can. So I'm going to go over the project spec, and then let me start with the data set. So I was given three options for the data set. So the first was the IMDb data set, then the Yelp data set, then the Twitter sentiment data set. So the IMDb data set is binary classification. You could do positive or negative. The Yelp data set is also binary classification, positive or negative. But the spec was asking me for classifying to classify text as positive, negative, or neutral. So which means that I have to go to Twitter sentiment dataset because that's the only dataset in the list that actually classifies tests and that contains the classification for output for neutral, positive, and negative. And the Twitter dataset is quite interesting as well. Twitter is a social media space. We have different users with different use of English, different wordings, weird characters and emojis, hashtags and link and the heart mentioned. So yeah, very, very interesting. So after the data set is chosen, the first step is definitely to do the pre-processing and data set cleaning. So I have this done locally in I'm coming, although yep, we could have it here. Data, okay, this one is for loading it from organ face data sets and to prepare the splits. And there is one for a moment, please. Okay, yeah, so we have I'm coming process, yeah, pre-process. So pre-process, so we have this to check for the URL, this to check for the mention, um, and also like non-English Unicode characters, of course, to escape those as well, to normalize the text basically. And for TF-IDF, we also the normalization went as far as removing the extra spaces, though it kept the spacing between the word and also removed punctuations. So we have just the word actually, and this is going to help for easier vectorization since that deals of course, with vectorization. So after the preprocessing is done, I have this done in notebooks, the EDA done in notebook, the exploratory data analysis, so that I could easily visualize I could easily visualize the data and also make decisions from the data. So the exploratory data analysis actually help to realize or to see that the data is actually skewed. We have a skewed data set. So looking at one diagram over here, we could see that obviously in the three categories, the trend set is like the highest, and then we have, yeah, sorry, not the trend set. Yeah, the trend set is the highest, and the neutral is like the highest category of the three sets of the three splits. But then when you look at it in the validation area here, in this place, you can realize that the neutral and the positive, they are of the same height, while negative is down. And over here, you can see that the neutral is the highest, followed by the negative, then followed by the positive. And you can see in this place the distribution is different. So what this tells us is that our training doesn't have to just be a generic training. It has to be a weighted training to take into account the skewness that exists in the data set, which obviously is the skewness that exists in real world as well. The world is skewed. So so it is a weighted training, weighted evaluation, and I used micro F1, obviously weighted as well, to actually assess and evaluate two the two models after training. So the baseline was trained locally. It was trained locally with my machine, TIFDF, into multinomial logistic regression. Multinomial because it's not binary. So we have three categories and then a softmax run over these three categories. So the data is cleaned, the classes are balanced, the pipeline is loaded, the text is vectorized, then feeds, then run, then evaluated. And then we have a generated confusion matrix. You can see the diagonals. Yeah, quite okay. Okay, yeah, of course it could. We could go on, look at different hyperparameters tuning, or actually have like a grid search of several hyperparameters, or even run the process for longer epochs. Well, actually, it looks good. We have negative, neutral, and positive. Of course, the values are quite a bit much. And for this test set, you can see the diagonals are basically, yeah, maintained. And we also actually took out like the top words for each category, the negative, the neutral, the positive, and they all seem pretty reasonable. And the TAIFDF with the multinomial logistic regression actually served as our baseline because the stillbirth run then have to actually surpass or be like the same level as the baseline. So for the distillbirth run, I actually had to duplicate some functions into this notebook because I could not run it locally, and this means that I have to sync the notebook with Cargo and actually run it on Cargo's free GPUs, then download the artifact, which is the model, the quantized model, and the training summary, and the tokenizer just JSON, and actually download everything and into a zip and actually put it back into the repo because I don't have a distant what's the name? I don't have a GPU connected to my machine or even a collab connected. Yeah, because the collab connected to the collab server connected to VS Code sometimes malfunction. So that's the way I used to do it. There could be better ways of syncing this through Cargo or collab, but that was the way I did it. So I set the notebook up locally and yeah, look through the function, cross-check the function to see if everything is correct. Choose the hyperparameters locally through some benchmarks run, and then synced it over to yeah, I chose it through some benchmark run, and also I looked up the internet for some constant defaults to actually see okay, what is good for this data set, what's default for this data set, and also um constants peculiar to the model which I'm running, which is the distilled birth based on cased. So it was after running the model outperformed the baseline by I think 8 points. Yes, 8 point. And then the float 32 model was then quantized was converted to Onyx. Yeah, it was converted to Onyx format and then quantized to int 8, which shrunk it down from 264 megabytes to around 65 megabytes, which is very, very like it makes it very efficient, faster, and it can sit in the repo. So the quantization didn't really affect the performance, and the loss was just about 1 point. So very, very small, very, very small loss. Not it's negligible. So and then the quantized version with a training summary, you can say quantized to int 8 with a training summary. And also before I also brought it back, I think I tested it with I tested with the Onyx runtime to actually test the if if the model is actually good for inference, and then it was brought locally, and then I rerun the eval to confirm the baseline and the distillbirth model and confirmed it's actually functional. After the model was done, I had the API built next. So the API was built with Fast API. Fast API handles everything. So we have the entry point, which is the main.py, and then the middleware, and then the schema, and the config, and the inference file, which includes the Onyx runtime for serving the distill birth model. The inference, yeah, I also did the routes for the batch predict, and the health, the ready, the endpoints, dependencies, the engine, the cache for the Redis. I also I added the Prometheus instrumentation for observability, but I thought it was over engineering, so perhaps it's not needed in this simple project. So I actually um, got it off for simplicity and to make everything explicable. So the fast API on its roots, it's actually serving the web that's it's serving a web HTML. um, Let me see. Yep. So it's mounting a web HTML by the root with the static file directory. So and this makes for easy visibility, and so that you can actually play around with the app without going to the docs. Of course, you could go to the docs and look through everything, and it's all easy actually. So it means that even if you don't want to download or clone the app locally, or you don't want to go through the app, or you don't want to go through the docs, which might be not be intuitive for some people, you can basically just go to the web interface and type in your text, just like I demonstrated earlier, and click classify, and it classifies. So we have the make file. Oh, of course, before I talk about the make file, let me talk about the Docker containerization. So Docker is used to containerize the app, the fast API, the API directory, so that it can run on Windows, it can run on Linux, and basically the dependencies or the environments don't really affect how it runs and what runs. So it's um yeah, in the fast API app, it's the Docker file containerization, and also this Docker Compose. It actually helps to bring up the Redis app. So we have the Redis runtime, sorry, not the Redis app, the Redis runtime server, and also it builds the Docker image. And the make file contains basic commands which makes for easy setup locally or perhaps in some sort of environment. So like one I'm gonna demonstrate is the make app. So you can run make up and it sets up the app locally, like it runs the Docker image, it does everything, blah 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 blah. And then when it's built, it serves at localhost 8000, localhost 8000. Yep, again, it's not done. Blah, blah, blah. I'm coming. Let me check. Uh, wow. So it's done, and this is running locally. Of course, this is an HTML entity tag, but you would input anything you want, be it emojis, HTML entity tag, and those go through pre-processing. Yeah, the pre-processing that was done in training is also done at inference time since it's very, very fast. The latency is negligible. So, and it does the classification. So, and basically, we also have this requirement.txt was generated because of the spec that is in um, the document sent across to me. It's not actually needed because I use UV for the virtual environment management, but definitely pip pip requirement.txt is also in this, and this is the web file. Just it just includes the favicon, which is just a simple right angle triangle which is aligned to the right, and then we have an index.html which contains the HTML, the CSS, inline CSS, or is it in script CSS? And then we have the scripts in the bottom, the JavaScript script. Very, very simple, very basic. And that is the project. So we have the baseline, which is TIFDF with multinomial logistic regression. And then we have the advanced model, which is the fully fine-tuned distill birth model on the classification, which classifies text in positive, negative, or neutral. So let's end this with a demonstration. Um, this is nice. Positive. Thank you very much.